Hi guys, I'm Enrique and this is Enzyme Art TV. Today we're going to go over how to draw a robot. The origin of the word robot comes from the Czech word robota, meaning servitude or forced labor. In our culture, the function and form of these robots has become as limitless as a human imagination. There are so many shapes and designs portrayed across media that your choices are nearly endless when it comes to creating your own. Have you ever noticed that the general concept of a robot in film or print isn't so different from human anatomy? Humans are engineered with a rigid base structure, a muscular system for motorization, a sensory system that sends and receives information, a power source, and a data intelligence center that controls it all. Thinking of parts of a robot in some of the same terms of understanding will make it easier for you to brainstorm design concepts. No matter what the concept, your robot is basically guaranteed to have degrees of freedom. These are any sorts of joints or parts which move or bend. For example, look at this robot. It has 4 degrees of freedom. Compare that to the degree of freedom of a human arm. Consider that for every degree of freedom, there is some sort of motor which drives its movement. And just like in the human body, individual moving parts are connected by joints. It's always a good idea to start brainstorming in thumbnail sketches before you find yourself with Picasso-style R2-D2 buried in eraser dust. A commonly used technique is creating a silhouette of your overall design. Are you making a bipedal robot? Are you making one with 4 legs? Wheels? Deciding a silhouette you like best will help you commit to the framework. Another more avant-garde way to do this would be to practice simple shape exercises, allowing the shape to influence a story and the story to influence the shape. Just don't let yourself develop paralysis by analysis. In the design stage, simply focus on proportion and shape. Perspective comes later. An important tool to have in your artist toolbox that comes into play with intricate builds like robots is the concept of areas of complexity versus areas of simplicity. In any drawing, there is potential for areas of tension, which tighten up the picture, and areas of simplicity, which let your eyes relax. What makes a picture visually engaging is a contrast between the two. So, while too simple and plain is boring, too much complexity might make the drawing too dense for the viewer. In a 2D image, trying to include all these intricacies might oversaturate your design and make it too dense for the viewer to appreciate. Once you have everything planned out, now it's time to start the drawing. For this example, my robot is going to be standing on 2 legs, and I'm also going to mark where the pivot points on the robot will be. I've worked out the proportions already, and the next step is to go into more detail with my mass shapes. Basically, I'm deciding what smaller shapes make up the larger ones. When I'm going into detail like this, it's making me consider more the functionality of specific parts. What is going to move this arm or that leg? It helps the function of your design to make sense, but this part doesn't have to be 100% accurate. It's not like you're making a blueprint. With that being said, it's nice to know about general mechanics, if you're hoping to make a robot that's slightly more believable than Matthew Broderick as Inspector Gadget. Joints are usually powered by an electrical motor, hydraulics, or pneumatic. An actuator can make a motor itself function. And as far as the most common joints, here are a few that I've seen. Rotational joint, a joint that pivots in one area, like our elbow. Linear joint, a joint that moves in a straight line across one axis. Twisting joint. Orthogonal joint. This is like the linear joint, but can also move 90 degrees. Ball joint. The human shoulder is an example of a ball and socket joint. Now when you're putting all this together to draw a technical robot, your picture is going to look a lot better if you make your strokes in a single hit. When drawing skin and organic material, there's room for more sketchy technique. But since you're literally dealing with a metal and factory-made object, you want hard lines. Which brings us to our next topic. Toning up your dexterity will help you achieve solid but accurate lines for your bots. Here are 3 exercises to improve your dexterity. Exercise 1. Draw 2 dots a good distance from each other on a piece of paper. Try to connect them with one stroke. Repeat until you hit the mark or reach a point where you're consistently getting close. Exercise 2. Draw a curved line on paper and try to thicken it slowly. Exercise 3. Draw a curved line again, but this time try to fill in the negative space with circles and ellipses. As long as we're talking about improving your technique, we might as well talk about line thickness. Line thickness is a great tool to establish perspective, contour, and abbreviated detail. A 1 is a very thin line, a 2 is a medium thickness, and a 3 is a very thick. If you want to define a contour or show that something is closer to the viewer, a 2 is a good bet. A thicker line also can be strategically used to suggest a complexity within. This could be important when making decisions to simplify certain intricacies in the mechanics of your robot. Unlike extreme perspective, which I go over in my superhero video, defining perspective on an object with a lot of straight lines and hard shapes is much more subtle and reliant on little details. The general concept is the same. Everything that's closer to the observer appears bigger and diminishes in visual size the further away it gets. The difference is that when you deal with a human body, you can kind of cheat shapes because humans are fleshy and organic, with distinct recognizable form. But when it comes to robots, with their mechanical pieces and combinations that are much less recognizable to us, we have to rely on pulling away in straight lines. You can use a ruler for this, but it's a good idea to start training yourself to do it freehand, as it improves your pencil control. Because robots are man-made, I think that robots are some of those diversified creations in science fiction. Robots tend to reflect humanity in some way, whether it be by their nature or in their design. Probably because we humans are their creators. So whether you draw from human anatomy, practical engineering, or virtual advancements, it's time for you to go out and make your own creation. Be sure to use the tips that I gave you. So be sure to check out our website and subscribe to this channel. Thanks a lot, guys, and stay creative.